Gelunda, and this is the ATD YouTube channel. Today I'm going to talk about this high voltage battery. This is a battery for a Smart Fortwo electric car from 2012 year model year. So excuse me about my English, but I think you understand what I'm going to talk about. First I have to say that a high voltage battery is a battery with three main features. I'm going to show you this level with the camera, and I'm going to explain you about those features. So here we have the characteristics about this battery, and you can see here three main things. The first thing is its voltage. This is the nominal voltage. This battery has 340 volts. Apart from that, this battery has 52 amps per hour. This is the capacity. With this feature and this feature, we obtain an energy inside of the battery of 17.6 kilowatts per hour. Okay, you can see too its weight is very heavy battery. A high voltage battery in electric car are made by lithium cells. Lithium is a material used for electric car batteries or electric motor batteries, because its cells has a lot of energy inside. So I'm going to take this cover apart and we will see what we have inside. I'm not using isolated gloves because this battery is totally discharged. So in case we have the battery with plenty of charge, we will need to use it. Okay? Pay attention in safety recommendation, safety procedure to disassemble high voltage battery, because are dangerous. Okay, so we can see here the battery. Very beautiful, this battery. So I have to say that a high voltage battery consists in many cells put together in series. I mean, when I say that they are connected in series, that means that the positive pole of one cell is connected by the negative pole of the next cell. Same with others. So with this kind of connection, we get more voltage with the same capacity. So for having 340 volts, we will need 93 cells connected in a row in series. So the beginning of the starting point for connection is this point, at the end is this point. Okay, so if we connect the multimeter to measure the voltage, we can see that this voltage is totally discharged. We are going to put this wire here and this another wire here, volts. Okay, so if I connect, we obtain 17 volts. So imagine what is the problem. It's totally discharged. Okay, I'm not going to talk about the problem, I'm going to talk about the battery. Okay, so first we know that a high voltage battery consists in many cells connected in series. Then the current through the series goes from the initial to the final point. For connecting different parts of the battery, you can see here one part, a second part, a third part. So we have a bus bar. That bus bar are used to connect the series from one group to another group. Okay, so this first group is connected to the second group with this bus bar. Even the second is connected to the third with this bus bar, and then we find a final point here and initial point. The initial point here goes from this bus bar to through a contactor, and the other one goes to another contactor. Okay, so if we disconnect, you can see a fuse, an enormous fuse. Okay, so from this point at the end and from this point, between those points is the same as I measured from here to there, is the same. Okay, and what does the contactor, what's the aim of this contactor? The aim of those contactors is to connect the high voltage battery to the vehicle. Okay, so here we will have the connector cable to the inverter converter assembly. So when the control unit, the VMS, the control unit who manage the completely battery, when it decides that everything is okay, it supply energy to the contactors, and the contactor closed and the voltage goes to the car. When you turn off the car, the contactors will be open and the car won't have voltage. The voltage will be inside the battery. Apart from that negative and positive contactor, we have here a pre-charge relay and a resistor who is used to connect the high voltage to the vehicle, preventing an arc flash. Another thing more things you have to know is that every cell is supervised. I mean, here we have 1, 2, and 3 VMS, another VMS, a VMS for one group, a VMS for the second group, a VMS for the third group, and VMS for the battery. So this control unit controls those three control units, and each control unit controls every group of cells. So it's very important in lithium-ion lithium batteries to control the voltage and the temperature of each cells, because lithium is quite a bit dangerous, so it needs to be very controlled. Even we have in the back side of this battery, in the back, we have pipes from cooling. This is a intercooler, a cooler. This one cooler and the second cooler for this group of cells, one cooler and the second cooler for this group of cells, and one cooler for and the second cooler for this third group of cells. So the battery needs has to be controlled in its temperature. If intensity goes out or come in, the temperature of the cells rises, and the cooling system will be extract the heat of the cells to prevent a damage. So that's the main part. As you can see here, they are very interesting, and we will talk more about batteries in our YouTube channel, for our ATD YouTube channel. See you soon.